In today's OpenGL demo, I'm showing off this physics-based rendering scene that has text rendering on it and a special debugging. So as you can see here, we can fly around, and this is our same physics-based rendering scene from last video, but now we have an FPS count up in the top left-hand corner, and we have text rendering across the center of the screen. And we can resize our screen, and we see that they all stay in proportion. Alright, so let me explain how the text rendering works. So we have this special header file I created here called Text.h, and it takes in glad, glm, and it needs FreeType 2, which is a library you have to install for it to work. But then we have this namespace text with the code for a shader here, and then we create this character struct, which takes in a texture ID, a size, a bearing, and an advance. And then we create a map of those characters, and then we also forward declare a shader program, a projection, a VAO, and a VBO, and then we store screen width and screen height. So the first thing we do is we have this setup function, which we take in a font file path, a screen width, and a screen height. The first thing we try to do is initialize our FreeType library, and we error if it doesn't work. Then we initialize our FreeType face, and if that works, then we come down here and set the pixel size equal to 92, or 96, sorry. And then we check to make sure it works with a letter, so we just check X, and then if that fails, it returns. And then what we do is we go in here and we for loop through all 128 of the default characters, and for each of them we create a texture, and then we store that texture into a character struct, the one we showed up before, where we take in texture. We create two vec2s, one of a bitmap width and bitmap rows, and the other of bitmap left and bitmap top. So what these are special values generated by the font and the FreeType library, and what they determine is the shape of the letter. So the letter P is put down a little because the bottom of P hangs below all the other letters. Some letters like O are much bigger than L, so that handles all of that. And then we also get an advance, which is how far along should you move for each letter. And then we insert that into our map of characters. And then once we're done with that, we ft done face and ft done FreeType, and then we set up a shader here. So this is all the code for a shader, and it doesn't use the shader.h class, so this works all by itself. And then once we're done with that, we'll enable GL blending and screen alpha 1 minus screen alpha, so this allows us to actually have transparency so that there's not like a block behind all the letters. Then we set screen width and screen height equal to what we inputted, and then we generate and set up both the VAO and VBO. Then down here, our other function, or 2 out of 3 functions, we have render text, which takes in the message we want to render, an X position, a Y position, a text scale, a color, and then optionally you can input another program if you don't want to use the built-in one. So we first get a projection from screen width and screen height, and then we set scale equal to the text scale value that we inputted times our screen width divided by 1600. So this just means that if you blow it up or shrink it, it doesn't change the scaling, it remains proportional. Then here we use our shader, set in text color, projection, and text from these values, activate our texture, and then bind our VAO. And then we have this const iterator, std string const iterator. So this is going to iterate through all of the characters. So we go for C equals text begin, C is not equal to text end, C++. And then for each of these, we get our character from the map, and then we calculate an X position and a Y position using the values we inputted from here, right here. And then for X position, we add ch, so that's the character's bearing.x times scale. And then for the Y position, it's a little more complicated because we take in size minus bearing times scale. And this allows characters to be rendered below lines such as P or Q. And then we have a W value and an H value, and this is simply the size times scale. Then we generate a 6x4 vertices. Then we set that to the subdata of the buffer, because of here when we create the buffer, we actually just leave the data empty. We just allocate the memory, don't use it, so we can fill it up here. And then we draw the triangles and advance x by our character.advance. And then down here, we send an error if you get an error, so OpenGL errors after setting up character. And then we bind vertex off and we bind the texture off. And then the last function is update screen size, which simply lets you reset screen width and screen height. So how do you use this in your code? Well, it's pretty simple. Wherever you change your screen width and screen height, just call update screen size. Once before your program runs, call this text.setup and pass in your font, your screen width, and your screen height. And then in your render loop, you can simply call text, render text, and then pass in the string you want to render here. So these are our two text renderers, and then this is the frames per second. And you see we add toString of 1.0 divided by delta time. And then you pass in its X location, and this is, so the bottom left-hand corner is 0, 0, and then the top right-hand corner is your screen width and your screen height. So for this one, we pass in 5, which means we're 5 pixels from the very bottom left on the x-axis, and we're 90% of the y-axis. And then we set the scale equal to 0.7, and we set the color equal to teal. And then for our debugging code, I can show it off here. So we can test an error message because active attributes is not a texture. So we can run this. All right, so now that it's loaded, you can see if we drag this away, we get error, invalid enum called from line 454. And if we go here, that is where our debug statement is. And the way this code works is it's another header file. It just needs glad. And then in our namespace, we have a glCheckError function. And we basically say, well, true, we check an error. So glCheckError. If the error is 0, we break, we stop checking. But otherwise, we have this big switch statement that lets us list all the errors that we found. And then for each error found, we also say where this function was called from. And both of these files, even though this one's a little unoptimized, it could be better, both of them will be in the description down below if you want to check them out. You should check out this video here. If you want to see how we get the rest of this scene to load with all the textures and all the spheres,